Alright, algebra, moving on to lesson 16, more on modeling relationships with a line. That's what we're working on the past few lessons, and we're going to continue to build upon everything we've learned about least squares line, best fit line, same deal, just different words, and residuals. Okay? First of all, calculating residuals. The curb weight of a car is the weight of the car without luggage or passengers. The table shows the curb weights in hundreds of pounds and fuel efficiencies in miles per gallon of 5 compact cars. Using a calculator, the least squares line for this data set was found to have the equation given, where X is the curb weight in hundreds of pounds and Y is the predicted fuel efficiency in miles per gallons. The scatter plot of the data is shown, and the least squares line is shown on the graph. You'll calculate the residuals for the 5 points in the scatter plot. Before calculating the residuals, look at the scatter plot. Okay, we look at the scatter plot. Above, above, way below, above, above. These are pretty close. This is way off. This is sort of off. Okay, so let's look at everything. Will the residual for the car whose curb weight is 25.33 hundreds of pounds be positive or negative? If you look at the table, that is the first data point in the graph. So will the residual be positive or negative? Well, if the residual is above the graph, we're going to take the actual value minus the predicted value, and the predicted value is lower, so it's going to be a positive value. And if you look, it actually gives us 3 miles per gallon positive, which is about 3 units above the line. Will the residual for the car whose curb weight is 27.79 hundreds of pounds be positive or negative? 27.79 is the third value, which if you look at the graph, it's the one that's way below. So if we do actual minus predicted, it's going to be negative because it's way low. And if I do the math, I get negative 6 miles per gallon. So it's 6 units below the line. Now we can confirm these residuals by doing the calculations. The 2 previous questions I did just by eyeballing it, where I would take the actual, count over and read, where it hit the predicted, count over and read. That's the residual. And then the one that's way down, come over here and read it, where it hits the predicted, and that right there is your residual. Okay, but here we actually calculated it and got a positive 3 and a negative 6, so we did a pretty good job. Now go ahead and write in the rest of the table. Okay, we have actual, 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 and we're going to use the equation y equals, where is it at? 78.62 minus 1.5290 times x, where these are my x values, and these are the y values. So if I plug in x equals 26.94, I get a predicted y value of, hold on a second. So I got a predicted value of 37.43. I'm now calculating the residual, which is actual minus predicted. I'm going to plug it into that value right there, and I get 0.6. Do that again for x equals 30.12 and x equals 32.47. Okay, give me a second. You can calculate this on your own and follow along. All right, for x equals 30.12, did the calculations, got the predicted, did our subtraction there, and we get 1.4. For x equals 32.47, got our predicted miles per gallon, subtracted it from the actual, and we have about 1.0. Okay, those are our residual values in miles per gallon. Not too difficult. All right, suppose, oh, looks like I have, oh, there we are. Calculate the remaining 3 residuals. Done, see above. Now suppose that a car has a curb weight of 31 pounds. What does the least squares line predict for the fuel efficiency of this car? Remember, we call that least squares line our best fit line, our predicted line. I'm going to do what I did in the last page. That gives me 31.2 as a predicted fuel efficiency. Would you be surprised if the actual fuel efficiency in this car was 29 miles per gallon? If you look at the chart, let's see. I'm going to do, actual minus predicted, and that gives me 1.2 as a residual. If I look at my chart, my residuals go anywhere from negative 6.1 to positive 3.1. So a residual of 1.2 is okay. I'm not surprised because it falls within the range. Example 2, making a residual plot to evaluate a line. It's often useful to make a graph of the residuals called a residual plot. You will make the residual plot for the compact car data set. Plot the original x variable, curb weight in this case, on the horizontal axis, and the residuals on the vertical axis. So that's a big deal. The x variable on the horizontal axis and the residuals on the vertical axis. For this example, you need to draw a horizontal axis that goes from 25 to 32 and a vertical axis with a scale that includes the values of the residuals you calculated. I believe we went anywhere from negative 6.1 to positive 3 point something. What was it? 3.1. Next, plot the point for the first car. The curb weight for the first car is 25.33, 100 pounds, and the residual is 3.1. So we're going to plot this point right here, and it's on the next page. So there you have it. We have the first point, which is 25.33 and 3.1. Okay, notice we have our dark line at the y equals 0 line. So if we look at the next point, I'm going to go back up to the chart. I have 26.94, comma 0.6. So 26.94 is about 27, and 0.6 is right. Let me get a better pen. 27, roughly right there. That's not bad. Maybe a little higher. Yeah. The next value we have is, 27.79 and negative 6.1. 27.79, negative 6.1. About right there. 30.12, comma 1.4. 31.4. Pretty close. And then the last one is 32.47, comma 1.0. 32.5. right about there. Okay, so you would have plotted that along with me. Now let's talk about that. The next question says, how does the pattern of the points in the residual plot relate to the pattern in the original scatter plot? Looking at the original scatter plot, could you have known that the pattern of the residual plot would be? The scatter plot, the first point, if you look at it, was pretty far away, and that third point was pretty far away. We talked about it before we moved on, right? So that's a really large positive residual and negative residual. These second, fourth, and fifth dots were pretty close to the line fit. So it makes sense that they would hug the 0 axis pretty tight. Okay, so it makes sense. The ones that are further away from the line fit will be further away from the residual. They'll always be on the top or the bottom, depending on where they are on the line fit graph, the scatter plot. And I think that's all. Let's see. You always know that the points above the line in the original scatter plot were closer to the line than the 1 point below it. So we expect the points above the 0 line in the residual plot to be closer to the 0 line than the 1 point below. All right. Oh, we did this. And we just talked about this. And we're done. The predicted y value is calculated using the equation of the least squares line. Best fit. Predicted y value. The residual is calculated using that equation. Residual equals actual y value minus predicted y value. The sum of the residuals provides an idea of the degree of accuracy when using the least squares line to make predictions. The sum of the residuals. To make a residual plot, plot the x values on the horizontal axis and the residuals on the vertical axis. Well done.